Hey, hi friends. So, so today we'll try to solve this lead code problem, minimize XOR. So the intent of this tutorial is not to code with you, but to teach you a mental model, to improve a mental model, how to approach this kind of questions in the real-time interviews. So let's get started. So you are given two positive integers, num1 and num2. You need to find out a positive integer x such that x has the same number of set bits as num2 and the value of x XOR num1 is minimal. So here XOR is the bitwise XOR operation and you need to return the integer x. Now if you see some examples, for example, I take the first example. Num1 is 3 and num2 is 5. So my num1 is 3, num2 is 5. So we need to find out a number x which has the same number of bits with num2, and if I XOR it with num1, then it should give minimum result. So first things first, we need to find out how many number of bits are there in num2. So for that, if we write the binary representation of 5, so it will be 1 0 1. So there are two bits in num2. So x will also have two bits. So x can be anything. X can be 0 1 1, 1 0 1, 1 0 0 1, anything it can be. But we need to give the answer x such that if x is XORed with num1, then it will give the minimum result. So one intuition over here is, if we want to get the minimum results, then most of the bits, like we our intention will be to make the resultant bits 0. So if we do a XOR of a number, if there are two numbers, if we do bitwise XOR, 1 and 1 will make 0, and 0 1 and 0 will make 0, and 1 or 0 or 0 1 1 will give us 1. So our intention will be that x will have two bits, right? So we need to accommodate these two set bits is number x such that we get minimum result while XORing with num1. So now if I write the binary representation of num1, so it will be 0 1 1. Now if we want to minimize this number with XORing with x, so we need to accommodate the bits in such a way that the position of the set bits of x matches with the set bits of num1, that is 3 over here. So that is one intuition. So if 1 and 1 matches, then it will become 0. So this is to make the result minimum. Now suppose we are given a number 2, a num2, which has only a single set bit, for example 4. 4 is basically 1 0 0. So then which bit we should accommodate it, in which position the bit of x we should accommodate? So the answer is, since we need to minimize it at a maximum point, so we will take the set bits from left, because this bit is specifying is basically 1, this bit is specifying 2. Now these bits will be like 2 to the power 3, 2 to the power 2 to the power 2, 2 to the power 3, 2 to the power 4, like how like this it will go on. So here we are given two bits we have to accommodate. So first we'll accommodate this bit. Okay, so then after that this bit is left, so we will accommodate this bit. So if we make our number, final number as 3, that means x is equal to 3. So 3 XOR 3 will give me 0. 0 is the minimum number we can get, and also x has the has only 2 bits as set, similar to num2. Now if we take a different example, for example 1 and 12, let's see how it works. So we need to find out, there are basically three scenarios we can think. Suppose in num2 we have a number of set bits, in num1 we have b number of set bits. If a is equal to b, then we don't need to worry about that, I mean, how to arrange the bits. So basically, our x will be is equal to num1b, because we'll be accommodating a number of set bits in the same positions in number one num in num1. Okay, that was the case in first example. Now there can be two other kind of cases. For example, a is greater than b. That means we need to set greater number of bits than num1. For example, suppose I am given a number like 7. So if I do a binary representation of 7, so it will be 1 1 1. Okay, now if I am given a number num1, for example 3, so 3 has set bits 0 1 1. Let take it as 5. Num1 is 5, so binary representation of 5 is 1 0 1. So the first step would be, if a is greater than b, first we'll accommodate b number of bits in the position of num1. So what is b here? B is here is equal to 2, right? So from a is equal to 3. So from 3 we will try to accommodate 2 bits in the same places of num1. So I place one bit over here, another bit over here. Okay, now I have one remaining bit, that is 1 bit I need to place. Now how to place it? I can place that bit anywhere in this. I can place it, suppose here are the hidden zeros, right? I can put here 1, or here 1, and here 1. So where I should put it? I should put it in such a way that the result becomes minimum. So I will try to put the bits from the right hand side. So I will check from the right hand side where is a free bit, like where the bit is unset. So the first bit I see that is unset is over here, right? So I will put it over here as 1. So my final result will be 1 1 1 is 7. So this is one scenario. And another scenario is a is less than b. That means the number of set bits in num1 is greater. For example, if I have been given num1 as 7, and a is basically num2, so the number of bit sets is in num2, for example, that is 1. Suppose we are given a number 1 7, the binary of 7 is this, and the binary of 1 is this. So we need to find a number that if we XOR it with 7 will give us minimum result, and it has only one set bit remaining. So obviously we'll first try to accommodate the positions where the bits are set in num 1. So we'll try to accommodate it from the left hand side. Why? Because we need to minimize the result as low as possible. So we'll come from towards the from the left, we'll see the first set bit is 1, so we'll keep it here as 1. So we need to only accommodate one bit because b is 1. So my final answer will be 100. So now if we do 100 is basically 4. So if we do a XOR of 4 and 7, we will get 3. So this is the minimum result we can get. So how to then approach this problem? If we have a num1, I am just summarizing. If we have num1 and num2, if num1 has x number of bits, num2 has y number of bits. If x is equal to y, then we can write the answer as num1 directly. If x greater than y, that means we need to accommodate less number of bits. Then what we will do, we'll try to accommodate the bits from the left hand side. Suppose I take a random binary representation of num1 and I need to replace one bit only or two bits only, then I will check from the left. I will bring here a bit, one, and then second. Okay. And if for the other case, if x is less than y, that means first of all we need to accommodate all the bits of the num1 position, num1 number. Then we'll try to see from the right that what is the unset bit of num1. Suppose here I need to suppose this is my num1. Now my num2 says that I need to set 4 bits. What I will do, I will first match these bits 1, 2, 3. So 1, 2, 3. While matching will come from right hand side. 1, 2, 3. Now I will go from left right hand side to see that how many more number of bits we need. For example, we need total number of 5 bits to set. So 3 bits are already there. We again need to uh, add 2 more bits. So we'll come from right. We'll say okay, this is unset, make it 1. Okay, this is unset, make it 1. So, what is the intuition behind this? You don't need to mug up anything. Okay. The intuition is whenever we have excess number of bits, we need to set it up. We need to increase the result as minimum as possible. So, we are starting it from the right because this is the index of 2, this is the index of 4. So, my final answer will be 1001111. I think this is very clear to you how to achieve this and how to code it, that you can find out in different solution. Also, I will attach a solution in the comment section. Thank you. Now,